Hi, okay, so this is a couple of tricky examples of Born-Haber cycles. We're going to look at two. The first one is a normal Born-Haber cycle, but this time the iron has two atoms of one of the things that make it up. So you can see here you've got your first arrow, which is your formation. That's the thing that's unknown. You have to ignore all the arrows I've drawn over it. It's the second time I've had to make this video. And then we've got here your magnesium changing from a solid to a gas. I've highlighted it in pink, so you can see that's the delta H atomization of magnesium. That is 150, because you can see the atomization of magnesium 150, so that's the value in black there. For this one here, you can see the thing that's changing is in green. I've circled it. Chlorine, Cl2 gas to 2Cl gas, that's atomization of chlorine. It's changed from a molecule to two atoms. So that's delta H, atomization of chlorine. Now you can see that that is one molecule going to two atoms. Now atomization is the energy required to make one atom. So that 121 value, you need to times it by 2. So that's 242 when you times that by 2. So that's this change. The change here, you can see I've circled it in blue, is your first ionization energy of magnesium, 736. The bit here that's changed is in purple, and that's from your Mg plus to Mg2 plus. That's your second ionization energy of magnesium, which is 1450. For this one here, you can see that the thing that's changed is two chlorine atoms taken the two electrons that magnesium has removed, and it's become two lots of Cl minus ions. So again, that's one thing that there's two of, and it's your electron affinity of chlorine. So it's 346, but it's done it twice because there's two atoms there. And so that's two lots of 346. So that is 692. Your lattice enthalpy is this one here, which is minus 2,528. So you put all your values in. Now, a tip I'll give you is when I do any Born-Haber cycle, I automatically, the first thing I do is I look down here at the ionic solid. Magnesium chloride. So there's two lots of the Cl, so anything that there's any numbers for, whether it be a 2, 3, 4, whatever, it makes no difference. The thing that there's two of, find up here and just put a times 2 next to the numbers in the boxes so you don't forget to do it, because you will. I do. So two lots of chlorine, there's a chlorine there, times 2, chlorine times 2. You don't need to change the things like the formation and the lattice enthalpy, because it's the big numbers at the beginning. So big 2 there, big 2 there. And of course that's magnesium, so you don't worry about that. So the atomization and electron affinity with times 2. So you can see the roots. You look for the area where the place where the two arrows come out of. So an arrow down here and one up here. So clockwise versus anti-clockwise. So you do plus 150, plus 242, plus 736, plus 1450, minus 692, minus 2528, and all of that will add up to your delta H formation. So that's your first of your tricky Born-Haber cycles. Not that tricky really, but